Lesson 2, we'll be covering some more review material, at least for some of you. But this is content you're really going to need to know in Math 121, and that's why we go over it again, even though some of you have already seen this. So we're going to be talking about equations of lines. We're going to review the concept of graphing and slope, and then eventually talk about how you actually write the equation of a line. You can find this content in sections 3.1, 3.2, and 3.3 of your textbook. So example 1, the equation 3x minus y equals 4. Example 1, the equation 3x minus y equals 4 is an example of a linear equation. It's linear because there aren't any exponents other than 1. And there's two variables, an x and a y. So that means solutions to this equation are going to have two numbers, such as the point 1, negative 1. That's an ordered pair. We always put the x first and the y second. So this is saying, is the number x equal 1 and y equal negative 1 a solution to this equation? Well, the easiest way to determine if it's a solution is just to plug those values in and see if you get a true statement. 3 times 1 is 3, minus a minus is a plus, and yep, 3 plus 1 is 4. So the point 1, negative 1, is a solution. Now, if we want to visualize or graph all solutions to this equation, and in fact there are an infinite number of solutions, one way we could do that is create a table of values. We could just pick some x's, figure out the corresponding y's, and then plot all those points. So for example, if x is 0, if I plug 0 in for x, 3 times 0 is 0, so I get minus the 6, I get minus y is minus 2, divide by negative 1, so it looks like y would be 2. And if x is 3, 3 times 3 minus y is 4, so 9 minus y is 4, minus y is minus 5. Again, divide by negative 1, and y equals 5. All right, so let's plot these points. When x is 0, y is negative 4. That's right there. X is 1, y is negative 1. X is 2, y is positive 2. And x is 3, y is 5. Notice that these points all lie in a straight line. That has to happen. That's why we call these linear equations. If your points don't lie in a straight line, then you probably made a mistake somewhere. Mine do, and so I'm just going to connect the dots. And there's a graph of this line, or you can think of it as a graph of all of the solutions to this line. Now it's also useful to talk about the slope of a line, or the steepness, or you could think of it as the rate of change of the line. And slope is defined to be the rise over the run. So basically that means when I draw my line, the rise would be how much do I have to go up, and the run is how much do I have to go over. We can also write that as a formula. I have it right here. Slope equals change in y, that's the rise, divided by change in x, that would be the run. So if we want to find the slope of a line, there's a couple different ways we can do that. We can use this formula that I just gave you. Slope is change in y over change in x. Or some of you might remember from a previous class that there's kind of another important formula here that has to do with lines. And that's our slope-intercept form. Maybe you've seen this before. Y equals mx plus b. We call this the slope-intercept form because m stands for slope and b stands for y-intercept. So basically what this equation, this formula, is telling me is that if I can take the equation of a line and solve it for y, then the number in front of the x is my slope. So for example, if I have the line 3x minus 4y equals 8, so I'm going to take this equation and put it in that y equals mx plus b form, or slope-intercept form. So basically that means I have to solve it for y. And so I'll move the 3x over by minusing it. Now I've got negative 4y equals negative 3x plus 8. And then to finish, we divide everything by negative 4. And now I have the equation y equals 3 over 4x minus 2. Notice that the negative divided by a negative gave me a positive. And so this slope-intercept form, y equals mx plus b, basically tells me that the number in front of the x is my slope, and the other number is my y-intercept. So to answer this, the slope would be 3/4. So the slope of this line is 3/4. In other words, that means if you were graphing this line, you would have to go up 3 and over 4. So again, if you were creating a graph, you would move up 3 units, over 4 units, and that would give you another point on that line. So if we're given the equation of a line, we can find the slope by solving for y, and slope is just the number in front of the x. If we're given 2 points instead of an equation, that's when we can use that formula. The y equals m equals rise over run, or change in y over change in x. So in this example, I'm going to say that the first point, the 2, negative 3, is my x1, y1, and 5, 1 is going to be my x2, y2. Let me fix that, y2. Okay, so slope would be change in y, so that's going to be 1 minus negative 3 over change in x, 5 minus 2, so that becomes 4 over 3. And so in this case, my slope is 4/3. Again, this is a rise over run, so that means we would have to go up 4 and then over 3 to get back onto that line. Okay, so again, to summarize, if we want to find slope, if we have an equation, it's the number in front of the x. If we don't have an equation, we can use this formula, change in y over change in x. And finally, this is the part that I really want to focus on. If we want to write the equation of a line, there's several different ways to do this. But the method I want to show you today, the method that I actually want to focus on in this lesson, is using what we call the point-slope form of the equation of a line. This is basically a variation of that slope formula. If slope is defined to be rise divided by run, then notice if you multiply both sides by the run, you end up with a new equation that says the rise equals the slope times the run. Or in other words, the change in y equals the slope times the change in x. And this has to be true for all x's and y's on that line because the line has a constant or the same slope. And so basically this formula lets us write the equation of a line if we know the slope and we know any one point, any x1, y1 on that line. Now, there's other ways to get equations. This is just the method I like. This is the method I'm going to be showing you because this is going to come up in Math 121 as well. So if I want to find the equation of a line with a slope of negative 2, my m is negative 2, and my point is, let's see, it goes through the point 2, negative 3. So my x1 is 2, and my y1 is negative 3. And so what I can do is just plug those numbers into my formula. Y minus negative 3 equals negative 2 times x minus 2. And then we can take this equation, we can actually get rid of the parentheses. So y plus 3 equals minus 2x plus 4. And I can even solve for y by minusing the 3. And so y equals negative 2x plus 1 is my equation. That equation is in what we call slope-intercept form now. So the basic idea is if I want to write the equation of a line, I have to know the slope, and I have to know one point, and then I can just plug those into my formula. So let's look at one more example. I'm going to use the same formula. Anytime the problem asks me to write the equation of a line, I immediately think about this point-slope formula. So I need to know the slope, and I need to know a point. And in this problem, they don't actually give me the slope. Instead, they give me 2 points. But that's enough information that we can compute the slope. We know that our slope is our change in y over change in x. And so my x1, y1, I'm going to let that be the first point, negative 1, 3. And I'll say that x2, y2 is the second point they gave me, 2, 5. So that means my slope would be 5 minus 3 over 2 minus negative 1, or 2 over 3. So plugging these numbers into my formula, y minus y1, so y minus 3, negative 1, x minus x1. I'm going to try to get rid of parentheses. So let's see, y minus 3 is 2/3 times x plus 1. And then we can distribute that 2/3. That would be 2/3 times x. 2/3 times 1 is 2/3. And then finally, I'm going to add 3 to both sides. Oh, I need a common denominator if I want to add fractions together. So I'll use 3 as my common denominator. So that means we are going to take 2 over 3 plus 9 over 3. That would be 11 over 3. So final answer would be y equals 2/3 x plus 11/3. And I do want you to leave these numbers as fractions. I don't want you to convert them into decimals. You're going to get rounding errors if you change everything into decimals. And many of the web work problems are actually going to ask you for fractions. And so it's a good habit to kind of get used to working with those fractions. So once again, because this was review material, I know if you took Math 050, you've seen this before. It's possible you saw this in a math class a very long time ago. But I know not everyone took Math 050, and some of you, your last math class was maybe 10, 20 years ago, or maybe you just haven't seen this material. And so I know I went fast through this. I'm trying to get through the review material quickly so that we can actually spend a little bit more time on the newer concepts. But that doesn't mean I don't have time to go more slowly with you outside of class. So if you've never seen this before, please send me a message. I'd be more than happy to meet with you during office hours.